Hello, everybody. My name is Chad Houston, and today we're talking about rules to help you figure out the numbers that you need, or how to write correct orbital notation and electron configuration for any element. And the first principle we're going to talk about is the Aufbau Principle. Now, what does that mean? This means that anytime we're going to fill a level and sublevel, we always want to start at the very lowest level and sublevel, completely fill it, and then go to the next level and sublevel. So now the question is, how do you know which levels and sublevels are lowest in energy? It follows this beautiful, wonderful, fantastic little chart over here called the Aufbau Chart. This is going to be fantastic. You're going to love this. Okay, so when it's written in this order, whenever you're given electrons, you need to fill it in this order. So let's say you have electrons. You start filling the 1s sublevel. And what's the most I can put in any S? 2. So I can put 2 electrons in this one, and I tried to draw an arrow there. Okay, so that's the 1s sublevels filled with 2 electrons. Let's say I have 2 more electrons. This level and sublevels filled. Now I go to the 2s level and sublevel, and I can completely fill that level and sublevel. So the 2s sublevels filled, because again, S's can only accept 2 electrons. Let's say I've got more electrons. Where do those go? Well, now we go to the 2p sublevel. So there's the 2p sublevel. We can fit 6 electrons in those. We keep going if we have more electrons, and then the next level and sublevel is the 3s level and sublevel. Okay. So again, we've put 2 in here in this 1s2, or this 1s can fit 2 electrons. We then go to the second energy level and sublevel, 2s. I can fit 2 electrons in that orbital. Then I've got more electrons, let's say. If I do, I go to the second energy level, okay, and there's the p orbitals, and there's 3 of those. I can put 2 in each one, so I can fit a total of 6 in there, right? Then I go to the next one, which is the 3s, 3s, and I can put 2 electrons in there, 3s2. Once that's filled, where do I go next? Well, let's follow the path. I can now go to the 3p. I can put 6 in there. I keep going, and I go to the 4s next. Now, everybody says this. They're like, wait a minute, I did something wrong. The thing that I did wrong was I went ahead and I went to the 3p. I filled all those with as many electrons. That's a total of 6, because remember, those p's are there. Next, I went to the 4s sublevel before I went to the 3d. Why is that? How come we can do that? Well, because the quantum mechanics, when they opened up the hood of the atom, they found that the 4s sublevel is lower in energy than the 3d. So after the 4s, we fill the 3ds. We can put a total of 10 in there. Then we can put 6 electrons, because again, there's a p there. That's the 4p sublevel. And then we can put 2 in that one, and we just keep going. Okay. So this one right here, and again, then we just follow the path. So basically what this tells us, and we'll probably never go higher than level 6, but essentially what this allows us to do is that it just says, what are the energy levels and sublevels we start with first? Now remember, and again, I'm going to go back to this, anytime, and we're going to type this in here, anytime we have an s orbital, the most we can fit, there's only one of those, and the most we can fit in is 2 electrons. Okay. Now, if we have a p orbitals, which are like our clouds, again, we have 3 of those, and we can fit in 6 electrons. Okay. Okay. And then finally, we have the d's orbitals. We have 5 of those, and we can fit 2 in each of those spaces. That's a total of 10 electrons. Okay, and then finally the s orbitals. There's a total of 7 of those orbitals. You can put 2 electrons in each one for a total of 14 electrons. Okay, And we follow this path. You follow these arrows. We go from the lowest level and sub-level up to the highest. We'll probably never go beyond 6. We could if we wanted to, but probably. Okay, so now the next thing we're going to look at is just a couple more rules so we can start doing this. Okay, so now we know that whenever we have electrons, the Aufbau principle states you want to start with the lowest level and sublevel first, completely fill it until you move to the next level and sublevel. This Aufbau chart is invaluable. It gives us the correct order that works 90% of the time. We'll talk about the exceptions later. So let's take helium. We're trying to find the quantum numbers for helium. Well, helium has 2 electrons. I could put them in any of these levels and sublevels. Well, according to Aufbau, we start with the lowest level and sublevel first. And that would be the one on the bottom floor. It goes in the 1 level in the S orbital. And again, in any S, the most I can put in are 2. So I have a couple ways that I can show that. If I'm doing the orbital notation with the arrows as electrons, I could write it one of 2 ways. I can write an arrow like this, and then an arrow up, but that would be incorrect. And the reason is we have the proper number of electrons. However, there was another idea here that says whenever we have 2 electrons in the same orbital, that is the same little space here, the 1s, the sublevel there, they cannot be spinning or going in the exact same direction. So then what I'm going to do is I'm going to back that up, and now that means it would have to go down. So this would be the correct orbital notation for 2 electrons for helium. And the way that I would do that for the electron configuration is we could say, hey, this is 1s2. 2 is not an exponent. It says on the first level, the S sublevel, I have 2 electrons. It's a filled level and sublevel that we could, this is the electron configuration when I write it this way. I'm going to put that right here. So this way we call it the electron configuration. The other way with the arrows, we call it the orbital notation. Let me get that there. So we're going to put it right here. Let's call it orbital notation. Now let's do another one. Okay, so when I look down here, let's take carbon. Carbon has a total of 6 electrons. Okay, so if carbon has 6 electrons, where would the first 2 go? Well, the first 2 would go in the first level in the S sublevel. And when we put them in there, that's filled. Okay, and Pauli says it has to go up and down. Now, that's 2. I have 4 more to go. The next 2, again, so I've done this one, I go here, it goes in the second level in the S sublevel. That being the case, here's the 2s right here. So we put, again, Pauli says 1 up, 1 down. The S's are filled. Now I've got 4 left. Okay, so we filled the 1s sublevel, we filled the 2s sublevel. Now I'm at the 2p. How many orbitals are there of p? Well, there's 3. I can put 2 in each one. This is the 2p sublevel. I have 4 left. I can do one of 2 things. Okay, so hang on a second. I have 2 left. I'm sorry. I have to count right. There are 6 electrons. I have 4. I have 2 left. I can either spread these out like this, okay, or I can double them up. Now, there's another rule, which we're going to get to here, called Hund Rule. And what Hund Rule says, I'm going to put that in right here. Okay, Hund Rule. This is what I call the school bus rule. Hund Rule says electrons spread out in the same sublevel before pairing up. Before pairing up. So what that means is that if I have a choice of spreading these out, pairing them up first, or I have a choice of, I'm going to try and carefully erase this, hang on, or I have a choice of spreading these out, okay, Hund Rule says, please spread them out first. So I can put one here, and I can put one here. And they're going to spread out first, and then when they're all spread out, then you start to double up. So this would be the orbital notation with the arrows for carbon. If I were going to do this, I could also, I'm going to try and draw this in here for the electron configuration for carbon. I could call 1s2, 2s2, and then 2p, 2p2. So that's 2, 4, 6 electrons. And again, so we follow the Aufbau rule. We start at the lowest level and sublevel, fill it up first. We followed, if we're doing the orbital notation with the arrows as electrons, anything in the same sublevel, in the same orbital, they're opposite. So they're going opposite. And then Hund Rule says you need to spread them out. Okay. So that's the basic. And then what we're going to do from here on out is practice, practice, practice. There you go. And we're going to learn all kinds of things about this, and I'll show you a bunch of shortcuts as well. So let's do some practicing, because I think when you practice a few of these, it'll make more sense. So let's take, for instance, 7. 7 is the atomic number for nitrogen. Nitrogen has 7 protons and 7 electrons. So let's say we were trying to find the quantum numbers, both the orbital notation, that is with the arrows, and the electron configuration for nitrogen. And we're going to use 3 rules. Aufbau, which is starting from the lowest level and sublevel and building up. Then we go to the Hund Rule, which means if you're on the same level and sublevel, you want to spread them out before you pair them up. And then we want to look at the Pauli exclusion principle, which means if you've got 2 electrons in the same place at the same time, you don't want them spinning the same way, and that is shown by the arrows. Let's take a look and see how this pans out. I'm going to go to Adam Smith, and there's a really nice feature on Adam Smith, and we'll get a chance to use this. Okay, so here's what I'm going to do. We know we have 7 electrons, so I'm going to put the first 2, because of Aufbau, go in the 1s, and there's only, like in every s, there's only 2 places, right? Every s. Now, in the p's, notice there are 3 different p's. We can fit 2 electrons in each one. And then, of course, we have the d's. And notice for the d's, there's 1, 2, 3, 4, 5 spaces, 2 electrons in each one. So again, these are levels, orbitals, and when we put the orbitals on the levels, we get sublevels. So the first 2 electrons, if I'm dealing with 7, would have to go in the 1s. And right there, it says we now have 1s2. Okay, and because of the Pauli exclusion principle, notice 1 up and 1 down. This level and sublevels filled. Because of Aufbau, we now go to the 2s. So now we're going to do this. Ready? So we go to the 2s, fill there, fill there. Okay, now that's filled. Now I've got 3 more left. So I'm going to do this wrong on purpose. Okay, I'm going to violate Hund Rule. So I'm going to go 1, 2. Okay, but then I'm going to put number 3 here. And what I should have done was put it over here, because the idea is if you have a level and a sublevel, and we've got orbitals, right, where we like here's 1 p, here's the other p, here's the third p. You want to spread them out first. Watch what happens when I check it. It says, hey, guess what? I violated Hund Rule. And the violation for Hund Rule, has every orbital gotten 1 electron before an orbital has gotten 2 electrons? No. Okay. So that's been violated. So I need to fix that. So I said, okay, I'll fix it. And instead of putting it here where it should go, I'm going to put it here. And again, what did I just do? Well, again, I have 1s2, 2s2, should be 2p3. I should spread it out. Instead, I violated the Aufbau Principle. I'm not filling this up first before going to the next sublevel. So let's check it. Sure enough, do all the electrons occupy the orbitals of the lowest energy levels available? No. Okay. Well, let's try this again. I'm going to take it out of this one. Take it out. I'm going to put it in here. And just for fun, I'm going to mess up another rule. So again, we've got 1s2, 2s2, 2p3. Everybody spread out, but I'm going to make a mistake on purpose. I'm going to say in the 2s sublevel, we're going to do this. We're going to put them both going the same way. Okay, and again, this violates principle. Let's check it. Oh, Pauli exclusion principle. In each filled orbital is one electron spin up and one spin down. No. Okay, so now I'm going to change it. And finally, what I'm doing is I'm going to check it. Okay. And as I check it, it says, congratulations, that's correct. Okay, so let's just go through 1s2, 2s2, 2p3. We spread them all out. If we can, then we'll start to pair up. And if any two are in the same sublevel and orbital, we have to make sure to have opposite spins. That's it. When you show the arrows, that's called orbital notation. When you show this like 2p3 and 2s2, that's electron configuration. Now, where did this HE come from? Well, because they don't have enough space down here, this is kind of shorthand. So what they're saying is when they put like HE in a core like this, they're saying, yeah, this is the noble gas configuration. This is a shorthand for these two right here. We'll get to that later. But the main thing we need to know is this is following the rules. Okay, now again, it's time for practice.